So good afternoon, everyone. Welcome to lecture 22 of the course Data Structure and Algorithm. And today, in the last class, we have discussed and understood about circular linked list, the code implementation of circular linked list, and its insertion of a new node operation. And I gave you a home task to implement the delete operation function. Okay, and today in today's class we shall discuss about a new topic which is queue. It's under module 2, so we will discuss few variants of queue in the next few lectures. Okay, so I hope all of you have studied the preliminary concept about queue.
Yes.
Okay, so I shall be demonstrating the code implementation first. Okay. So I have shared my screen. Can you see my screen? Is it visible?
Yes, sir.
Okay.
Yes, sir. Yes.
Right. So let's say we are supposed to implement the code, program code, the queue operations using array. Okay, for simplicity. Now, so suppose this is an array, and suppose the size of this array is 7. So this array is data structure is will be used to implement the queue. So like stack, we also want to fix the capacity of this queue. ठीक है? Fine. And we need actually two pointers or trackers. They may be simple variables or they may be some pointers. So as I prefer pointers, so I have taken two pointers. One of the pointer is named as front, another of the pointer is known as rear. This front is supposed to point towards the first most element of the queue, and the rear first most element means the element which has been added in the queue for the first time, and the rear pointer is supposed to point towards the last element, means the element which has been added into the queue latest, right? So front and rear. So initially front is pointing towards this position and rear is also pointing towards this position. Okay, so when the queue is empty, ঠিক আছে?
আচ্ছা স্যার, যখন কিউটা এমটি থাকবে তখন তো ফ্রন্ট আর রিয়ার দুটোকেই তো -1 দিয়ে অ্যাসাইন করতে হবে ফার্স্টে।
Front and rear I have taken as a pointer, not a simple variable.
আচ্ছা আচ্ছা।
Okay, you may initialize front equal to rear equal to null.
ইয়েস স্যার, নাল দিয়ে, হ্যাঁ মানে ওইটা, হ্যাঁ আচ্ছা আচ্ছা।
You can do so, no problem. So front and rear must be declared as global pointers. So I assume, and also I have to declare the queue as a global array. So this is the line through which I'm implementing the queue using array. So int queue, let's say 27. Not required, because I will be using a pointer. What can I do? I can use a symbolic constant. That's it. So as the array is defined as an integer array, and front and rear pointers are pointing towards the elements of the queue. So those are pointing towards integer values. So naturally, front and rear are nothing but integer pointers. So I can declare them here. Int star front, int star rear. Okay, and then I can do this front equal to rear equal to q. Okay, so now if I want to display, so here is the memory allocation already done. A vacant queue using array data structure has been created using the line number 10. This is the memory allocation line. And then I made front equal to rear equal to q. That means front and rear are supposed to point towards. Okay, so this q means the name of the array I just have provided here. The name of the array itself acts as a base address. Okay, so if you want to display the name of the array, it will show you the base address. So base
Sir,
address,
Q0 হবে ওটা?
q0 means zeroth element. It's not an address.
Yes, yes.
So either this one, or if you are not comfortable, ampersand of q0, address of the zeroth element. Okay, so this is array basic, that if I provide only the name of the array, it's behave like its base address. If you just display over here, is the font visible to all of you properly?
Yes, sir. Yes, sir.
Yes.
So let's see. See, base address equal to 2293.296. Okay. So the name of the array itself behaves like its base address, and that's why this syntax is okay. So base address is assigned to both front and rear. Now in this case, if I run the program, say 2293.296, 2293.296. Okay, that means this is the picture now looking like. Okay. So again, I recommend all of you, suggest all of you to follow me. How am I implementing the code? Step by step, I'm implementing the code in a smaller fragment and then validating what I want, whether it is coming properly or not. Okay. Next, these are coming front and rear. These are coming. Next, I want to add an element over here. I want to perform, okay, in queue you have two operations. One is addition of a new node, new element. Other is deletion of an existing element. Okay? And you don't have to ask the user for any position. It's position independent case. Okay. So let me build up a switch case here. So here I want to ask the user the value to provide the value of the element to be inserted. And then call the function. I have to pass that information. Okay. So here the information came element. So if I do, where I want to insert, add an element, suppose at any intermediate situation there exists some value 3, 4 like this, so that rear is pointing towards this. So what I want to move the rear pointer to the next level. Okay, and then I want to add a desired value, user given value over here. So first I need to move the rear pointer to the next position, next desired position, and then I want to add that element into with the help of rear pointer, right? So rear is a pointer, and to move it to the next position I can do it by simple arithmetic operation rear plus plus, right? And then using the pointer,
Sir, q rear equals to element.
yes, that's it. Okay, but this is a small error. Remember, this will be fine. Okay, so initially I have initialized front equal to rear equal to q. So as someone, probably Soham, has told me that if I do initialize front and rear both by null, then it will be a problematic situation. For example, if front and rear, not problematic situation means some problem will be there, and always I can overcome that problem. That's not a problem. Achha, okay. So if front and rear both are initialized to null, then rear plus plus front plus plus is meaningless. Both of them are pointing towards null, nothing. If front or rear is pointing towards some memory location, then plus plus minus minus is meaningful. But if front or rear is pointing towards null, then plus plus minus minus is meaningless. So we have initialized front rear to q, some memory location. What is that? Initially, address of the 0th location. Okay? So
Yes, sir.
what I want, so the logic is something else. If I don't do this first, if I do this first, star rear equal to element, and then if I do rear equal to rear plus plus, what will happen? So for example, so initially the queue was vacant, empty. So I have stored user given value over here 7, and then I have done rear plus plus. So rear is pointing towards this. So that means rear is supposed to point towards that position where a new element can be added, not the position where the last element added is present. Okay, so if I follow this convention, then these two lines of code will do my job. Okay. Okay. For example, let's test some also this case with other example. Let's say already some values are there, 765. So according to our convention, rear is pointing towards this. So then star new element is stored in star rear, means in this location. Star rear means the value of this location must be assigned the new element. That's correct. And then rear plus plus. So it is doing correctly those two lines of code. Okay, so for the time being, those two lines of code is properly doing my job, our job, right? That's fine. Okay, next.
আচ্ছা স্যার একটা জাস্ট ডাউট ছিল স্যার, আমরা যদি ফার্স্টে রিয়ার প্লাস প্লাস করি তারপরে স্টার রিয়ার ইকুয়ালস টু এলিমেন্ট করি স্যার, তাহলে তার ডিসঅ্যাডভান্টেজটা স্যার তাহলে কোথায়, মানে স্যার ড্রব্যাকটা তাহলে?
ড্রব্যাকের কিছু নেই, ওটা করলেও হবে, এটা করলেও হবে। এবার আমরা যে কোনো একটা কনভেনশন ইউজ করছি। প্রথমে
আচ্ছা
প্রথমে ইনিশিয়ালি when the queue is empty, so rear is pointing towards this, ঠিক আছে? Then if I do first rear plus plus, it is already moving to this location. This position is vacant, but still rear plus plus is due to rear plus plus, it is coming here and storing a user given value, this, let's say 5.
ও আচ্ছা, তার মানে স্যার তখন ফ্রন্ট প্লাস প্লাস আবার করতে হবে তখন হবে?
না, ফ্রন্ট প্লাস প্লাস এর কথা আসছে না এখানে। Addition require modification of front.
Yes sir.
ঠিক আছে? So this is the case. So that's why we are doing star here. Again, these two lines may be modified later. So let's see. So in using these two lines, let's see when the queue is empty, the function is called add queue. Element is coming. Element equal to, let's say 7. ঠিক আছে? 7. So star rear equal to 7. So what will happen here? 7 will be stored, and due to rear plus plus, rear is pointing towards this. Front is pointing towards this one. Next, again, I want to insert an element. Same function call is there. Star rear equal to element. Let's say the element value is 6, and I'm doing rear plus plus. So first 6 will be added to star this location, then rear plus plus. So this. Okay.
Yes sir, yes sir.
So next, again the function will be called using star rear. Let's say the value element is 5, it will be added over here, and then rear is pointing towards this. Next 4 is added, due to rear plus plus, it is pointing towards this. So those two lines are code working very fine. Keeping on adding elements, fine. So here 3, then rear is pointing towards this. Then here element is added 2, then rear is pointing towards this. Okay. Then again this function add queue is called. Due to star rear equal to element, let's say element value equal to 1. So 1 will be stored over here, then rear plus plus somewhere here. Okay, so what is the address over here? So suppose the base address q is equal to, let's say 100. and each of the location requires 2 bytes of memory. So address of this 0th location is 100. This will be 102. This will be 104, 106, 108, 110, 112, and this is 114. ঠিক আছে? And what is the size of the queue? 7. 7 is the size of the queue. So if I do q plus 7, that means what? Q value is 100, and I am doing address arithmetic. That means 7 means 7 into the size of the each element, that is 2 bytes. So it becomes 114. You can also do instead of q ঠিক আছে? So it is 140. So if rear is equal to 114, that means you have to understand that the queue is full, and that is important. If queue is full, you can't allow user to add any more element into the queue. So here what we want to do, if rear is equivalent to, let's say,
Size of
q plus the size, size is storing the capacity of the queue. So this means what you can do, you can handle that situation. Queue overload, delete some element. That's it. And then you return back. Okay. Otherwise, these 2 lines of code. Okay. So I think okay, here you have to put a break, otherwise fall through will occur. So I think it's done. Let's compile. Okay, so q is a local variable. So I need to pass the information of the queue also. Okay, so add element. Oh, sorry, we have not done the display. So compilation error is not there. Let's display. Okay, so again I need to pass. Okay, no need to pass. Front is already there. So in star traversor equal to front, right? So while loop here I want to display with the help of traversor uh, percentile D star traversor plus plus. So when the traversor is reaching the last element, so if the queue is full, okay, not full, let's this situation. So rear is pointing towards this. So initially traversor is pointing towards this, displaying the value 7. Traversor plus plus, it moves to this, display 6. Then traversor plus plus coming here, displaying value 5. Then traversor plus plus coming here, displaying 4. Traversor plus plus coming here. So when traversor equals to rear, that means you are done. So when traversor is less than rear, then it should keep on displaying the element. As soon as traverse will be equal to rear, while loop will be terminated. Okay. So now the question is, yes, we can do this comparison between two pointers, because the pointers are nothing but addresses. The traversor address is less than rear address. Okay. While this. Okay. Again, if the queue is empty, right, then traversor rear is pointing actually towards this location. So in front is equal to rear. Both are pointing towards same location. That means the queue is empty. If front equal to rear, printf queue is empty, nothing to display, add some element. That's it. And then return. Okay. Otherwise, it will do the while loop. So now let's try to, okay. Queue is empty, nothing to do, it's working very fine. So add element, let's say 7. Okay. Is it working? Yes, 7 hyphen. So now let's say 6, again 5. Let's check the overload condition. 4, display at this moment 7654. So it's working very fine. 3, 2, 1, right. 75. So it's working very fine. Now, what is that? It's asking for the value. Okay. The overload, delete some elements. So it is working very fine, right? So addition is implemented, Overload condition satisfied. Displays are working very fine. Now let's come to delete operation. So delete operation, simply you call delete function. Let's say del q. So here some elements are there, right? So let's say 7, 6. Okay, let's do this. The queue is empty, so nothing can be deleted. So again, you already have understood that this is the condition to check whether the queue is empty or not. So we will do this. Okay, so if front equal rear, queue is empty, nothing to delete. Add some element, that's fine. Otherwise, delete means, let's say some value is there, 7, 6, 5, 4, like that. Okay, and rear is pointing towards this location. So what should be deleted? 7 should be deleted. Together, 7. This should be deleted. Now, at this moment, two situation arises. Yes, which one you want to implement? Okay. So if 7 should be deleted, front should be coming to this. This is your new front element, 6, right? So this is one situation. So please try to understand what are the two situations here can be arised. That is number 1. Okay, number 1, after deleting, front moves to next element, which becomes the new, which becomes new front element, right? So you may do this. Or, and what is the problem in that case? And this is problematic, of course, and this is disadvantageous. Okay? Why? Because if you move the front like this element, this position will no longer be available to be used, to be filled up, and that is the disadvantage. Okay. For example, if you want to display after delete, how will you display? You have started displaying from front, traversal equal to front, and ending up just before rear. So it is actually trying to, it is displaying starting from front up to this element 4, 6, 5, 4. And if you keep on adding after this, here you can add, then rear is pointing towards this. You are adding here next, rear is pointing toward this 1. Will you be able to add any element in this position? After that, no. This is not possible, and that is the disadvantage. And this is the simpler case, simpler situation. But if you want to overcome this disadvantage, then little complexity will come. Okay, so what is that?
Left shifting.
Yeah. So front will not move, front will always be there, and you have to left shift all these elements so that a corresponding vacancy is generated in the last position. So which one you want to prefer? Number one is a simpler. Number two is little complex. Little complex means just you have to do the left shifting part. And this is new concept. New concept means probably in Kanitkar or somewhere. I don't know what they have done. I forgot. Okay, you will study. So this left shifting is not there in the book. ठीक है sir? So to overcome, front must be unaltered. Rest all to be left shifted. To create a corresponding vacancy in the last position. In the rear end, that will be fine. Okay. So let's do this. The first one. So if the Q is having some value 6, 5, 4, 3, 2, 1 like that. So what will happen? Front will be simply move to the next location, and before that you may display the value. So printf percentile D is deleted from Q, star front, okay, and then front plus plus. So if I do this, let's see, oh, delete function. If I do this, let's check. So add element 7, 6, invalid person, 5, 4, display. So these are the contents. Now we want to delete one element and then display what is happening. So everything is deleted from Q and then display. And let's see, 654 is displayed. So this is working very fine. So it is looking like, yes, my queue is done. My program is okay, very okay. It is running successfully all the operations, addition, element, but still there is some problem. I told you what is the problem. Okay. Okay. So this is the thing why I suggest all the students say, understand what you are doing, because you are the programmer, you are the builder of the algorithm. Okay, so your program is okay, it is showing, apparently it is looking like everything is working very fine, but still there is some problem. Okay, so if you do your program on your own and understand it, then you will realize where is the problem, where is not the problem. You can debug your program on your own. Okay. Okay. Acha, now we want to overcome this problem. Okay. To overcome this problem means here. So we will not do from plus plus. So 7 is deleted from Q. That's fine. But instead of from plus plus, we will be doing for logic. So from plus plus, so left shift. We want to do left shift. So how can we do left shift? So from front plus 1 to at this, okay, front plus 1 to rear is pointing towards this. So you can take a pointer, let's say shifter. Okay, let's say the pointer name is shifter. The shifter is actually pointing towards this, and it will shift this element to here, and then it will move on. Then it will shift this element to here, then it will move on. Then it will shift to this, and then it will move on. Okay, then it is shifting 3 here, it is moving on, shifting 2 here, and it is moving on. So when it reaches rear, when shifter is becoming equal to rear, then you have to stop. So I can use a while loop, and I'm doing left shifting starting from left, right, not from right. That will lose this data. Okay, so int star shifter, int star shifter, here shifter equal to front plus 1. Okay, so while shifter is equivalent to not equal to rear or less than. So it will do what? How is the shifting occurs? The value of the shifter pointer, that means let's say 6. So star shifter. Okay. Star, that means shifter is pointing towards 6. So star shifter gives you the value 6. And how to access this location? Shifter minus 1. So I can do star of shifter minus 1. Okay, that is equal to star shifter. Yes, shifter minus 1 means this one, this location, and shifter means this location. So this location is replaced by the value of 6. Okay, and only one line, oh, 2 lines should be there. After that, shifter plus plus. Okay, so at the end of the while loop, after the end of the while loop, shifter has reached to this location, and still this 2 is there. This 2 is there. It is not being replaced by anything. So what you can do, so after the left shifting, what is the scenario? Let me show you. 6, 5, 4, 3, 2. So this 2 is undesired. Okay, it's not an element. But what you can do, you can reset it to 0. That's also meaningless or meaningful. That's up to you. But what important is, rear should be pointing towards this. Okay, rear should be pointing towards this. Are you getting my point? Rear should be pointing. That means, what is the role of rear? By our convention, rear is the pointer which point towards that location where a new element to be added. That means it's a vacancy. So rear is pointing towards the vacant location where the new element to be added. ঠিক আছে? Okay, so let's test this.
আচ্ছা স্যার, একটা জিনিস, যখন রিয়ার যখন মানে ওখানে যখন পয়েন্ট করছে তখন নাকি 2 কি আছে অলরেডি তখন?
হ্যাঁ আছে, 2 আছে।
এই যে হ্যাঁ,
বাট সেটা থাকলো কি থাকলো না আমাদের যায় আসে না।
স্যার থাকলেও তো কিছু না, ওটা তো অলরেডি রিঅ্যাসাইন হবে,
ইয়ে হয়ে যাবে। আচ্ছা, ওভাররাইট হয়ে যাবে।
It will start displaying from here, and it will end display up to this. So up to this is your existing queue filled up.
Yes sir, yes.
It will be displayed, and whenever you want to add a new element, that element will be replacing this value earlier stored. That's not a problem. Or if you actually, if you replace this 2 by 0, that's also meaningless, because 0 may be a valid value element, and we
এমনিতে তো ওভাররাইট হয়ে যাবে স্যার ওখানে নতুন ভ্যালু।
override হয়ে যাবে। তো সেজন্য আমাদের এখানে কোথাও আমরা অ্যাজিউম করিনি যে 0 denotes a vacancy, ঠিক আছে, that's why we are
আচ্ছা
not
আচ্ছা
okay. So let's run the code. I think we are almost done. Add element, what is the value? 7 6 display 7654. Now let's delete element. Element deleted from queue. Now let's display 654. So it's apparently looking like fine. It's similar to the earlier one. Okay. Now, how can we test? Okay, how can we test that this left shifting has occurred or not?
We have to enter 7
সেভেনটা
elements.
আবার হ্যাঁ 7 এলিমেন্টস ঢোকাতে হবে।
So these are the 3 elements. So that means 4 vacancies are still there. So I can add 4 more elements that can test or validate, justify that yes, left shifting has occurred. But if left shifting has not occurred, then only 3
তাহলে 6 আরো স্যার
vacancies
6 এলিমেন্টসই হবে।
yes. So let's try to add some element. 3 2 1 see 3 elements already added. Now queue is overload, that message is not coming. Okay, let's try to display 6543217. Now add element, queue overload. Okay, so exit option is not there. So let me show you the, you have to convince yourself whether everything is working fine or not, even if the code is was working previously. Okay, so that's it. Okay, so any question up to this?
না স্যার ঠিক আছে।
And I told you that this is the logic this is the logic which has been added new, this line number 65 to 73, but you can do 65 only, that logic, no problem, but that is the core logic. So this is something new which I have introduced in this year. Earlierly I have not actually taught the students this logic, so first time. Okay, so thank you for listening. So I am done from my side. If you have any question, you can ask me.